Okay, now on that last problem, we were looking at numbers, right? Like you'd look at 216, can you divide that by anything? Well, there's no other numbers in the denominator, but I do see some x's, and that's good. That's good too, because if I see those, then I can simplify them, right? So I got my square root still, but now it's a full square root of 216 x to the power of 11 over x to the power of 6. Now, I actually purposely put this x to the power of 6 beneath the x to the power of 11 because those are the values we're going to work with. Okay, now let's go ahead and separate these two, though. So you got square root of 216 times the square root of x to the power of 11 over x to the power of 6. Now, it doesn't matter which one you start with. I like to start with the numbers. And why am I doing 216 right here? Because I think it can be simplified. Can it be? I don't know. I don't know for sure. Here's what I know, though, is looks like I can divide it by 3, which would be 72 right there, which is not a perfect square.
6 and 36.
So, yeah, 6 and 36, right? Now, could I divide anything between that? So is it divisible? 4 doesn't really help us because 36 is a bigger one. But it would be divisible by 4. Let's see what that is. That'd be 4 and, yeah, thank you, 54. But again, 4 is a perfect square, but it's not bigger than 36. We want the biggest one. 5, it's not divisible by 5, so that doesn't work. So 6 and 36 looks like that's the best one that we have. And so 216, again, we're going to look at it as the square root of 36 times the square root of 6. And the square root of 36 is 6. So now I have 6 times the square root of 6. Now, differentiate these two 6's, right? Like the green 6 came from the square root of 36, and the square root of this purple 6 is still in the square root. All right, so that's the numbers part. And by the way, if you just typed in the square root of 216 in your calculator, it would have given you 6 times the square root of 6, which is legit. It's a legitimate way to do this problem. But now we got to deal with those x's, right? So that's division of the base x's. So I am going to take the x base, I'm going to take the 11 and then subtract the 6. And it does have to be in this order. It's always numerator exponent minus the denominator exponent. So that would give me then the square root of x to the power of 11 minus 6 is 5. Okay, so I'm going to move this over here so we can do some work. So the square root of x to the power of 5, again, as an exponent, I would show this as x to the power of 5. But we would have to take that, and then that square root right there would take the 5 and divide it by 2. Now, if you do that, you'll get x to the power of, 2 with a remainder of 1. Right? So that then tells you got x to the power of 2, and then that remainder of 1 is a square root of x. Just make that red. Okay, so we have everything simplified. Let's go ahead then and combine our stuff. So on the outside, I would have the 6, and I would have the x squared.
I have a question.
So yeah, that. So I'll finish this one here. Right, we still have got some square root stuff going on. We have the purple 6, and then we have that square root of x. Put that one orange, just kind of related. So that should be our simplified answer. But yeah, let's go back to that 5 divided by 2. So I showed it with straight division right there. I kind of wanted to show it with long division, just so we know that we're looking for a remainder here. But yeah, you could have shown it as 5 divided by 2 like this. I don't know if that's a better 5, but it's a 5. Yeah, either of these ways to show this square root, either of these are good.